Hello, calculus kids. I miss you guys greatly. This would be so much easier if you were all sitting in front of me at the high school or anywhere, Caribou, wherever. But anyway, we will do our best. We will get through this and it'll all be just fantastic. Anyway, all right. So I hope you guys are all doing well. Like I said, I really miss you guys. And if you guys want to come on Google Live, there's a link on Google Classroom, and I'm there every day during your hour from 12 to 12:40. So, all right, here we go. All right, I'm going to go over one question that someone asked on live Google Meets, and I forgot to record it, so I'm going to go through that quickly. It's 7-1. It's question 8 of 13, and it talks about fluorescent compact light bulbs burning out. And I want you to notice two things, and I don't have my stylus yet. It's coming today or tomorrow, so I'm going to go ahead and record this, and the next lesson will be much better. All right, so it talks about the light bulbs burning out at a rate. That keyword rate right there, when it's talking about a rate, okay, that means it's a velocity or a miles per hour. So whenever you see rate, you know that. It also says bulbs per day. When it's talking about bulbs per day, again, that's like a miles per hour. So you know that that is a rate. So the question says, how many are going to be burned out after the first 100 days? So when you're going, how do you figure out? So if you're going 30 miles per hour for 2 hours, how do you figure out how far you went? Well, you would take 30 times 2, or you'd integrate the velocity. Whenever you integrate the velocity or integrate the rate, you end up with the number of. Now, I know if you tried this problem, holy cow, when you went to the answer explanation, they gave you all of this stuff about summation and change in t and all of this stuff you did not need. That's way a lot of information that you don't need. This problem is actually pretty simple once you know how to do it. You simply integrate the velocity. So you are going to integrate the velocity and your rate equation, and that is 7 force e to the negative 0.00175 t, and I apologize, like I said, I don't have my stylus yet, dt. All right, and then what do you put in for your limits of integration? Well, it's the first 100 days, so you're going to start at day 0, and you're going to go to day 100. And because it's dt, you know that those have to be t values, and your 100 days is a time, which is your t value. So you can simply just put that in your calculator. I'm not going to do it for this one. I'll do it for another one. But you notice I have the TI calculator up on the side. There is a link if you guys need a TI calculator to integrate. It can go on your screen. Don't forget you have to push the buttons over here as you're pushing. You can't like necessarily type in a 7, but I'll show you how to use that on a different problem. All right, so that is how you do question 8 of 13. And if you have questions again, you can ask friends, you can come on live with me during your class time, or you can go on that live anytime with other friends as well. That room is open 24 hours a day. All right, so next, okay, 7.2, just a quick review of 7.2. When you guys are looking at general rules for 7.2, which is area, there's 2 ways to do it. You can either areas base times height for a rectangle for most things. So when you're looking to find the area, you simply integrate the height, the top minus the bottom. And then if that's height, then the outside part, I'll point it right here, not with my finger, is, I'll get the pointer out, is dx. So this is your height, this is your width, and those are x values because this is a dx. Now, sometimes you can't go top minus bottom, you have to go right minus left. If you have to go right minus left, that is your width. So then this is going to be a dy, and these are going to be y values. So this is what we did on our last day together, which was Friday, March 13th. So that was 7.2. All right, so since Friday the 13th, we have been working, we've had the shutdown period, and then now we are finally starting 7.3. All right, 7.3 is moving from area onto volume. So how are we going to do this? All right, we're going to do our best. So when you integrate your the height, and then you have the dx on the outside, that gives you volume. So you're going, I'm sorry, that gives you area. So you're going from 1 dimension to 2 dimension. For figuring out the volume, you're going to integrate area. So for 7.3, the entire thing is going to be about integrating area. So when you're integrating area, sorry, that writing's bad. Okay, So when you integrate area, that is going to give you volume. So how are we going to do that? Okay, well, what does it say? It says find the volume of the solid generated by revolving the shaded area around the x-axis. So we're going to revolve that blue line that you see around the x-axis. So when you revolve that blue line around the x-axis, that's going to come down here and be at the bottom. So when you revolve that, if you turn your head sideways and look at it, you're going to get like a cone. It's going to look like an orange cone that they put out for traffic construction. So that's what it's going to look like. So when you take that and you revolve that around the x-axis, it's going to go like in front of the computer and then down and then behind the computer screen and then back up. So it's going to end up being a 3D thing. Volume is three-dimensional, 3D. So I'm going to try and draw the disk that you end up with around that area. So that's going to come out, it's supposed to be three-dimensional. I have trouble doing this in classroom, let alone online. All right, so what it's going to end up forming is it's going to form a disk. So this is called the disk method to find the volume. And if you look, there's actually all kinds of disks in here. It's going to make a whole bunch of disks, all the way from like when x is 0 is going to be your biggest disk, all the way over here to x is 9, which is going to be like no disk, but 8.75 will be a tiny little disk in there. There's like your 8.75 disk, a little tiny disk. So you have all these disks from 0 to 9, and what we want to do is we want to add up an area of all of those disks. So when you add up the area of all of those disks, you get the volume. So how do you add up the area of all of those disks? Well, you integrate the area and you will end up with volume. So that is going to be equal to the volume. So those disks is a circle. And what is the area of a circle but pi r squared? So for every single problem that you're going to do is we are going to integrate pi r squared. Oh, and if you revolve around the x-axis, this is a dx. If you revolve around the y-axis, which we're not going to do today, that would be a dy. All right, so since we're revolving around the x-axis, that's a dx. So then what are the numbers? What are we integrating from? Well, those are going to be x values. Oops, here. So we're going to put an x value here and an x value here. So this x value is 0 because it's the shape. I'm going to point here. The shape starts at 0 and goes to here. This is counting my 2s, 2, 4, 6, 8. That's 10. So that's going to end at 9. So 0 and 9. So we're going to integrate pi r squared dx. All right, so what is our radius? If you notice that nice little red line, that is the radius. That's the radius of that disk. We can also put in a radius of this disk, and a radius of that disk, and a radius of that disk. So what is that radius? The radius is actually going to be, what color do I want? That is going to be your height. That's your y value. From the x-axis up to the blue line is your y value. So what we're going to do is we're going to solve that blue line equation for y. So we have x plus 3y is equal to 9. So then we're going to get 3y is equal to 9 minus x. So we're going to get y is equal to 9 minus x, divided by 3. There's a little x writing there. Let me get rid of that. Okay, so it's 9. So that is your radius. So I'm going to go back in here and put that this is equal to your radius, because that is the height from up. That's your height up. And y is your height up from the x-axis up. So now when I integrate here, I'm going to go ahead and integrate. Oh, whoa, what was that? Let's just get rid of that. Okay. So I'm going to go ahead and integrate from 0 to 9 pi times my radius, which is right here. So that's going to be 9 minus x divided by 3 squared dx. All right, now that is the setup. That's part A of your question. Part B says, what is the answer? In exact form. That's kind of a bummer, it's in exact form. So if you put it in your graphing calculator with the pi in there, you're going to end up with the decimal. In exact form doesn't, pi is exactly pi. So what I'm going to do is I'm going to take the pi out. So I'm going to do pi, and then I'm going to integrate from 0 to 9, because pi is just a constant, you can do that. and go 9 minus x. Oh, sorry. Let me reset and go 9. Hang on. Go back to my writing tool. Minus x over 3 squared dx. Hopefully you can read that kind of. Okay. Sorry. Okay. So I just took the pi out. So then in my calculator, as you can see, I already have my equation in there. So then I can just simply do, if you remember, you do, to get the fraction, you go alpha y equals, that's your n over d. Okay, so I already put that in there. So now in order to get, in order to figure out what the integration is, you go second, calculate number 7, which is your integration, and we're going to go from 0, which is the x-axis, your x value, all the way to 9, and I hit enter, and I already did this, so you can see it already shaded in. So then it shades it in, and you get an answer of 27. So your answer is not 27. Your answer is actually pi times 27. Okay, and that is a times sign. I'll just make it really big. Let me just actually redo that. So your answer is pi times 27, which ends up being 27 pi, and that is your answer. Okay, and that is the volume of that shape when you revolve that blue line around the x-axis. So what that is taking all the area of all of those green discs lined up from the top to the bottom. It's like stacking up a bunch of frisbees that are different sizes that would make a cone. And then if you add up the area of every single one of those from the bottom to the top, you would end up with the volume of that shape. All right, moving on to the second one. The second type of problem you're going to have is this type of problem right here where they don't give you the picture. You just have to come up with your own picture. So that's fine. And revolving on the x-axis, that's good. It's going to be a dx problem again. So what I'm going to do is I'm going to draw my parabola, y equals 4x squared. 4x squared is a parabola. So there's a parabola. If you want to draw the exact one, you can do it on the graphing calculator. And then it also has y equals 0. So where is y equals 0? So that means you don't go up and you don't go down. So here is y equals 0. And then we also have x equals 2. So where is x equals 2? X equals 2 is like, I don't know, maybe right there. So we're going to put it here. There's x equals 2. So what we're going to do is find the volume of the solid when we generate that around the x-axis. So we are going to take that little shape here that we just found. So this little shape here, this little space, and we're going to revolve that around the x-axis. So when I revolve that around the x-axis, that shape is going to come down here. And again, we're going to get the discs again. So the discs are going, so it's coming around. It's like a volcano this time. It's like a mountain that comes to a peak if you look, if you turn your head. So we're going to get these discs here. So this is again another disc problem. So how do we do a disc problem to find the volume? We integrate the area, which is pi r squared. Okay, that's an R. I'll get my stylus, it'll be much better. Okay, so when we integrate that, pi r squared, this is your x-axis, so that's going to go from 0 to 2. So this is going to be dx from 0 to 2. So what is my radius? Once again, the radius is just the height from there to there, the height from there to there, the height from there to there. That height is simply your y value, because that's how tall that is from the x-axis, up to the top. So we are going to integrate from 0 to 2 pi times your radius, which is 4x squared dx. So once again, you can pull the pi out, put the rest in your graphing calculator, or you can integrate it by hand. All right. And for the last one, I'm running out of time here, I only got 45 seconds. For the last one, if you remember, that's a circle. That is a circle of x squared plus y squared is equal to 9. Okay? So you're going to have your shape, and it's going to look like this. And when you revolve it around the x-axis, it's going to come down here. And then your discs are going to be like this. So you're going to set up your discs from -3. This would be -3 over here to 3. So you're going to integrate pi r squared dx, and that's going to go from -3 to 3. All right, let me know if you have questions. I'll be live, and have a great day. 2 seconds left. Bye.